Hi, welcome back. Part 2 of terminal velocity. This is a second take. Fred, the custodian's here. He sneezed, so I'm doing another take. Terminal velocity. Well, when I was a kid, I remember the space program, Gemini, Apollo, the space shuttle the program just ended, and you see the animations, black and white TVs, of the re-entry to the Earth's atmosphere. And the air, the Earth's atmosphere is buffeting the spacecraft. Well, that's a force. That air, people don't think of air as having a force. Well, if a piece of matter is moving, it's going to apply a force. And that's the same thing with air. Air is made of molecules, oxygen, nitrogen, argon, etc. High budget. Remember this? Okay. Air gun. Okay. Shoot Fred there. Okay. Air. Harmless. Bed sheet. I use this with momentum. The egg toss. I have basketball players who can hit a basketball. They can hit it mid-court. They can sink a three-point shot, but they can't hit this. They make a mess. Yeah? So it can have an effect. When you're skiing, your face gets red from skiing. You wear goggles to protect your eyes. The air will hit your face. Friction. The cold air will dehydrate your skin. That's a burn. Wind burn. A burn can be from cold or hot. It's a burn. Okay, now, let's review terminal velocity just quickly, okay? Here I have weight. The book calls it W, okay? And that's downward force. It's a downward. Now, remember, the direction of the motion is positive. Direction of the motion is positive. Falling, down, positive. The weight, that's the force, positive. Upward, that friction, that air, we call it air resistance, but it's friction. Contrary, the opposite direction, negative. FW, FAR equals 0, equal opposite. Terminal velocity. Easy? Yeah? Okay. Now, in the book, they have an example in 6 parts. Someone jumps out of a plane. He's 100 kilograms. That means they have a weight of 1,000 newtons. Okay? Easy? 100 kilograms, 1,000 newtons. That's FW, or just W, we'll call it. Easy? They jump out of a plane. At the instant they jump out, there's no air resistance. He's not falling, or she is not falling. So the air resistance, that negative force, that friction, 0. Net force, 1,000 newtons. 1,000 newtons divided by 100 kilograms. You ready? Net force, 1,000 newtons. F net over mass. That's acceleration. Acceleration is a quotient. F net over mass. Plus 10. Why plus 10? It's plus. Mass is scalar. Mass is not plus. Plus over the scalar quantity, plus. Plus positive 10 meters per second squared. That's the acceleration. Now, he's falling. Hits some air resistance. We're going to call that resistance R, and it's going to be 400 newtons. Now the net force is 1,000 plus a negative 400, positive 600, okay? So now we have plus 6 meters per second squared. It's accelerating less. Be careful, tricky. My acceleration is less, but I'm still moving down, and I'm still increasing velocity. So my velocity is still increasing. I'm still increasing down. My speed is increasing. So don't make that mistake. think very carefully on that. Now, I've been falling for a while, and the air resistance is equal and opposite to my weight. No net force, 0 over 100 kilograms. 0 acceleration. Wait, I know this. Terminal velocity. 0 acceleration, constant velocity, terminal velocity. Yes, easy? TV. Terminal velocity right there. Now, I'm going to come back for part 3 and we'll finish up the problem. Make sure you view some of the other clips online to prepare for next week's quizzes. Thank you very much. And be careful out there.